Hello everyone, this is Ashwini, Assistant Professor of Computer Science at A.D.M.COLLEGE for Women at NAGAPATTINam. My topic is Software Engineering. The content, Introduction to Software Engineering, what is Software Engineering, Key Principles of Software Engineering, Main Attributes of Software Engineering, Dual Role of Software, Objectives of Software Engineering, what careers are there in Software Engineering, Advantages and Disadvantages of Software Engineering, finally conclusion. The first, Introduction to Software Engineering. Software is a set of programs containing instructions that provide the desired functionality. Engineering is the process of designing and building something that serves a particular purpose and find cost-effective solutions to problems. The next, what is software engineering? Software engineering is the process of designing, developing, testing, and maintaining software. It is a systematic and disciplined approach to software development that aims to create high quality, reliable, and maintainable software. Software engineering includes a variety of techniques, tools, and methodologies, including requirements, analysis, design, testing, and maintenance. The next, it is rapidly evolving fields and new tools and technologies are constantly being developed to improve the software development process. By following the principles of software engineering and using the appropriate tools and methodologies, software developers can create high quality, reliable, and maintainable software that meets needs to the users. Software engineering is mainly used for the large projects and based on the software systems rather than single programs or applications. The main goal of the software engineering is to develop software applications for improving quality, budget, and the time efficiency. Software engineering ensures that the software that has to build should be consistent, correct, also on budget, on time, and within the required requirements. The next, key principles of software engineering. The first, modularity, breaking the software into smaller, reusable components that can be developed and tested independently. The next, abstraction, hiding the implementation details of components and exposing only the necessary functionalities to other parts of the software. The next, encapsulation, wrapping up the data and functions of an object into a single unit and protecting the internal state of an object from external notifications. The next, reusability, creating components that can be used in multiple projects which can save time and resources. The next, maintenance, regularly updating and improving the software to fix bugs and new features and address security vulnerabilities. The next, testing, verifying the software meets its requirements and free of bugs. The next, design patterns, solving recurring problems in software designs by providing the templates for solving them. The next, agile methodologies, using iterative and incremental development process, the focus of customer satisfaction, rapid delivery, and flexibility. The last, continuous integrations and deployment. Continuously integrations, the code changes and deploying them into the production environment. The next, main attributes of software engineering. Software engineering is the systematic, disciplined study and appropriate to the design, development, operations, and maintenance of the software system. There are four main attributes of software engineering. The first, efficiency. It provides a measure of the resource requirement of a software product efficiently. The second, reliability. It assures that the product will deliver the same result when used in similar working environment. The next, reusability. This attribute makes sure that the modules can be used in multiple applications. The next, maintainability. It is the ability of the software to be modified or repaired or enhanced easily with the changing requirements. The next, dual role of software. That is the dual role of software in this industry. The first one is the product and the other one is the vehicle for delivering the product. We will discuss both of them. The first, as a product, it delivers computing potentials across networks of hardware. It enables the hardware to deliver expected functionalities. It acts as an information transformer because it produces, manages, acquires, modifies, displays, and transfers the information. The next, as a vehicle for delivering a product, it provides system functionalities. For example, payroll system. The next, it controls other software. For example, in OS operating system, it helps to build other software, for example, software tools. The next, objectives of software engineering. The first, maintainability. It should be possible for the software to evolve or meet changing the requirements. The next, efficiency. The software should not make wasteful use of computing devices such as memory, processor cycles, etc. The next, correctness. A software product is corrected with different requirements specified as the SRS document have been correctly implemented. The next, reusability. A software product has good reusability if the difficult models of the product can easily reused to develop new products. The next, testability. Here, software facilitates both the establishment of test criteria and the evaluation of the software concerning those criteria. The next, reliability. It is an attribute of software quality. The extent to which a program can be expected to perform its desired function over an arbitrary time period. The next, portability. In this case, the software can be transferred from one computer system to either environment to another. The next, adaptability. In this case, the software allows the differing system constraints and the user's needs to be satisfied by making changes to the software. The next, interoperability. Capability of two or more functional units to process data cooperatively. The next, what careers are there in something software engineering? The first, a degree in software engineering and relevant experience can be utilized to explore several computing job choices. The first, software engineering have the opportunities to seek well-paying careers and professional progress, although their exact possibility may vary depending on the particular school, industries, and regions. Following on the job choices in the software engineering, the first is software engineer, the next is software development engineer, web developer, quality assurance engineers, web designers, software test engineers, cloud engineers, front-end and back-end developers, the finally security engineers. The next, what task do software engineers do? The main responsibilities of a software engineer is to develop useful computer programs and applications. Working in a team, you would complete various projects and develop solutions to satisfy certain customers or corporate demands. Some of the key responsibilities of software engineers are requirement analysis, collaborating with the stakeholders to understand and gather the requirements to design and develop software solutions. The next, design and development, creating well-structured, maintainable code that meets the functional requirements and others to software design principles. The next, testing and debugging, writing the conducting unit test, integration test, and debugging code to ensure software is reliable and bug-free. The next, code review, participating to code reviews to improve code quality, ensures the standards and facilities knowledge sharing among team members. The next, maintenance, updating and maintaining existing software system, fixing bugs and improving performance, adding new features. The next is documentation, writing clear documents including code commands, API documents and design documents to help other engineers and future developers understand the system. The next, how much do software engineers make? The majority of the software developers globally make less than $15,000 annually on average. This covers not only junior developers but also some senior ones based on where they work and do for the work company. However, it is more likely that a mid-level or senior software engineers makes between $50,000 and $120,000 per year. What skills do software engineers need? To achieve success, software engineers require a unique set of technical and soft skills. These skills include computer programming knowledge for designing, developing, testing, and debugging software, as well as soft skills for interacting with the stakeholders, team members, and company leadership. Following are some must-have technical skills to become software engineer. The first, coding and computer programming. The next is software testing. The third, object-oriented design. The last, software development. Following some skills become software engineer. The first, communication skills, team player, problem solving, attention to details. The next, advantages of software engineering. There are several advantages to using a systematic and disciplined approach to software development. The first, improved quality. By following established software engineering principles and techniques, the software can be developed with fewer bugs and high reliability. The next, increased productivity. Using modern tools and methodologies can streamline the development process, allowing the developers to more productivity and complete projects faster. The next, better maintainability. Software that is designed and developed using sound software engineering practices is easier to maintain and update over time. The next, reduce cost. By identifying and addressing potential problems early in the development process, software engineering can help to reduce the cost of fixing bugs and adding new features later on. The next, increased customer satisfaction. By involving customers in the development process and developing software that meets their needs, software engineering can help to increase customer satisfaction. The next, better team collaboration. By using agile methodologies and continuous integration, software engineering allows for better collaboration among development teams. The next, better scalability. By designing software with scalability in mind, software engineering can help to ensure that software can handle an increasing numbers of users and transactions. The next, better security. By following the software development life cycles and performing security testing, software engineering can help to prevent security breaches and product sensitivity data. Software engineering offers a structured and efficient approach to software development, which can lead to high quality software that is easier to maintain and adapt the changing requirements. This can help to improve customer satisfaction and reduce cost while also promoting better collaborations among development teams. The next, disadvantages of software engineering. The first, high upfront of cost. Implementing a systematic and disciplined approach to software development can be resource intensive and require significant investing in tools and training. The next, limited flexibility. Following established software engineering principles and methodology can result and may limit the ability to quickly adapt the changing requirements. The next, bureaucratic. Software engineering can create an environment that is bureaucratic with a lot of process and paperwork, which may slow down the development process. The next, complexity. With the increase in the number of tools and methodology, software engineering can be complex and difficult to navigate. The next, limited creativity. The focus on structures and process can stifle creativity and innovation among developers. The next, high learning curve. The development process can be complex and it requires a lot of learning and training, which can be challenging for new developers. The next, high dependence on tools. Software engineering heavily depends on the tools, and if the tools are not properly configured or not compatible with the software, it can cause us issues. The next, high maintenance. The software engineering process requires a regular maintenance to ensure that the software is running efficiently, which can be costly and time consuming. The next topic, types of software. The software is used extensively in several domains, including hospitals, banks, schools, defense, finance, stock markets, and so on. It can be categorized into different types. The first, system software. System software is necessary to manage computer resources and support the execution of an application program. Software like OS, compilers, editors, and drivers, etc. come under these categories. A computer can't function without the presence of this. Operating systems are needed to link the machine-dependent needs of a program with the capabilities of the machines on which it will run. The next compilers. Compilers translate the programs for high-level language to machine-level language. The next application software. Application software is designed to fulfill the user's requirements by interacting with the users directly. It could be classified into two major categories: generic or customized. Generic software is software that is open to all and behaves the same for all of its users. Its functions are limited and not customized as per the user's changing requirements. However, on the other hand, customized software is the software product designed for the client's requirements and not available for all. The next, networking and web application software. Networking software provides the required support necessary for computers to interact with each other and with the data storage facilities. Networking software is also used when software is running on the networks of computers such as the World Wide Web, and it includes all the network management software, server software, security and encryption software, and software to develop web-based applications like HTML, PHP, XML, etc. The next, embedded software. This type of software is embedded into the hardware, normally in the read-only memory, that is the ROM, as a part of the large system and is used to support certain functionalities under the control conditions. Examples are software used in instrumentation and control applications like washing machines, satellites, microwaves, etc. The next, reservation software. Reservation software system is primarily used to store, retrieve information and perform transactions related to air travel, car rental, hostels, exam activities. They also provide access to bus, railway reservations. Also, these are not always integrated with the main system. They are also used to relay computerized information for the users in the hotel industry, making the reservations and ensuring that the hotel is not overbooked. Finally, we are saying conclusion. Software engineering can be expensive and time-consuming, and it may limit flexibility and creativity. However, the benefits of improved quality, increased productivity, and better than maintainability can outweigh the cost and complexity. Software engineering determines if it is the right approach for the particular software project. Thank you.